Section 6.4 talks about logarithmic functions. Before we start solving the problems on the homework, let's talk about what logarithmic functions are and what does logarithm means. So we're pretty familiar that 2 to the third power is equal to 8. And how do we get this? Because 2 to the third power means 2 times 2 times 2. And then when we multiply 2 3 times by itself, we're going to get an 8. So we all know that by this time, 2 to the third power is equal to an 8. And that's the proof. Now, when we talk about logarithms and exponential functions, they are inverses of each other. So when I say a question log, so this is the function for logarithmic functions, log, log, and then the base is 2, and the number will be here 8. So when I say this question, and if I convert this question to English language, so this question is asking what power is needed? What power is needed to go from 2 to 8? So basically, log means in math class, it means exponent. Log means exponent. So what this question is saying that if you have a 2 and you want to make it an 8, what power do you need? And since we know that 2 to the third power is 8, the expected answer will be here at 3. So logarithmic equations and exponential equations are always related. So when you have a log equation like this, you will always start from your base. So 2 to the third power is equal to the 8. So there is also a relationship like this. 2 to the third power is equal to 8. And then log means exponent. So when we see a log question, it means from this base number, we want to reach to this number. So what power we need? So the power we will need is 3. So 2 to the third power is equal to 8. So this is the main idea behind the logarithmic functions. Now we're going to actually just do the homework questions to understand this concept better. So the first question I got on the assignment when I opened it is find the exact value of log base 6 of 36. Again, so this question means I have a 6, but I want to convert it to a 36. So what power do I need? So I'm going to solve for power. So 6 to the what power is 36. So we all know that 6 to the second power is 36. So this question here, log means the power. So the power I need will be a 2 because 6 squared is 36. So all I have to do is mark here 2, check my answer, and it will be correct. So this is how we do number 1. I am going to do now number 2 on the homework. For number 2, the question I got is this time. We're going to evaluate this logarithmic expression without using a calculator. So I have log base 4 of 1. So I need to find what this answer is. So the question is 4 to the what power is equal to a 1. So because of the properties of exponents, any number to the power of 0 is always a 1. So even this was a 5, even 5 to the power of 0 is 1. Even 13 to the power of 0 is 1. So if you have a 1 on the other side of the exponential equation, the power must be always equal to a 0. So the expected answer here will be a 0. So all I have to do is type a 0 here, check my answer, and it will be a correct answer. Let's do now number 3. For number 3, the question I got is another logarithmic evaluation without a calculator. So I have log base 9 of 81. So this means I have a 9, but I want to make it an 81. So what power do I need? So the power I need is 2 because only 9 squared is equal to an 81. So I know that 9 squared is 81. So log means the power. So from 9 to 81, we need to raise 9 to a second power to make it an 81. That's what it means. For question 4, I have now log base 5. And then the number we have here is 1 over 125. So I have a 5, but I want to change it to a 1 over 125. So what power do I need? First of all, since the 5 became a fraction, first thing I know that this power has to be a negative power, because this is a very important rule. 5 to the power of 1 is 1 over 5. 3 to the power of negative 1 is 1 over 3. So I know that if this became a fraction, I have to have a negative power. Now, when I think about 125 is 5 to the third power. So this must be a negative 3, because look, if 5 to the third power is equal to 125, 5 to the negative 3 power is always 1 over 125. So this negative power will change you a fraction. So this negative power means we will get 1 over, and then 5 cubed will be copied to the denominator. So the answer I need here will be a negative 3 for this question. For question 4, we got this one. It is log, and base number is a fraction now. So the base number is 1 over 2, and we want to raise 1 over 2 a certain power, and it will become 128. So the base number is 1 over 2. I want to raise it to a special number, so then it will give me a 128. That's what the question is. First of all, 1 over 2, if 1 over 2 became a nice number like this, we will need a negative power. So if I just raise 1 over 2 to a negative 1 power, what happens is negative power means we will flip the fraction, so it will become 2 over 1. And then we are going to keep the same power. And 2 over 1 is the same thing as 2. So I'm going to raise 2 to the first power, which is 2. So if I just raise 1/2 to the negative 1 power, I will get 2. But if I raise 1 over 2 to the negative 8 power, let's see what happens. Negative makes you to switch this fraction to a 2 over 1 format. So that's what negative power means. You're going to flip your fraction, and then you're going to still raise it to the power of 8. So 2 over 1 is the same thing as 2, and then 2 to the power of 8 will give you a, it's not 8 actually, because 6th power is 64, and then this must be a 7. So I'm going to get a 7 here. We're just going to make this a negative 7 here for this one. And then I'm going to make this a negative 7. It just doesn't type it for me. So you know that we're going to get a negative 7 here. Yes, so for this question 5 on my assignment, this is not 8, but in my case, this is the 7th power. So the expected answer here on the homework will be, I'm just going to have to enter here negative 7, but for some reason, I'm not able to enter. So you got the idea. So we're going to move to the next question next. And then the next question this time is number 6. For number 6, here is what we have. I have log, and then the base number is 2, and then this is x, and then this will be equal to a 2. So now the base is, I'm going to handle it by converting it to an exponential equation. So logarithmic equations and exponential equations, you can easily convert them to each other. So if I understand what this means is, I have a number 2, and I will raise it to the power of 2, and then that number will be here, right? So, but if we just convert it to an exponential equation, the base is 2, and then we're raising it to a power of 2, and then we will set this to an x. So x is 2 squared. So in this case, the answer will be just a 4. So we're going to move to number 7 next. For number 7, we have this question. I have log base 4, and then this is x, and this is set to be a 2, and we want to still find out what x is. The best way to handle this problem is, again, writing its exponential equivalence. So the base number is 4, and then we're raising it to a power of 2. When I do that, it has to give me what the x is here. And 4 squared is equal to 16, so x must be 16 because only 4 to the second power is 16. Or that's how we do number 7 in this question. Next, we're going to do number 8. For number 8, I got this question. I have log base 2, and then we have the 2x plus 5 here, and this is set to a 5. So this is a logarithmic equation given to me. I am going to solve for x. I'm going to use the same logic as the previous one. So the base number is 2, and we're raising it to a power of 5. When I do that, it has to give me the number I see here, which is 2x plus 5. 2 to the 5th power is 32, and then this is 2x plus 5. To solve for x, we will subtract 5 from each side. So that is a 27, and then that's a 2x. And then if we just divide each side by 2, x must be equal to a 27 over 2 with this setup. And then for question 9 next, I have a very similar question, so we're going to practice this one more time. I have log base 2, and what we have here is 5x plus 2, and then this is set to a 3. So we want to solve for x. The base is 2. I am going to raise it to a 3rd power, and then this is set to 5x plus 2. So 2 to the 3rd power is 8, and then this is 5x plus 2. Subtract 2 on both sides. So I get 6 is equal to a 5x, and then divide each side by 5. So x will be equal to a 6 over 5 for this question. Number 10, what I got is log base x, and then this is 361, and this is set to a 2. So I'm going to again change this to an exponential equation. So the base is x. We're raising x to the 2nd power, and this is set to a 361. So I actually got a number that I'm not familiar with. So I don't know what number to the power of 306, what number to the 2nd power gives me 361. So I'm going to think, I know that 15 squared is 225. I think that's all I know. Maybe I know that 16 squared is also 256, so I need something bigger. I want to check what 17 squared is. So 17 times 17. And then this is a 17. No, this is still very small, 289. So none of these work so far. So I need a number bigger than 17. It cannot be 18 because 18 squared must be an even number. So this is not an even number. So what about 19 squared? So if I multiply 19 by 19, 9 times 9 is 81. 8 is the carry. So I'm going to get 179 here, and this will give me and 1. That is a 6, and then this is 361. So that means x must be equal to a 19 for this question, and this is how we do number 10. For number 11, I have an easier question. I have log base x, and then I have a 9 here, and this is set to a 2. So the base number is x. We're raising x to the power of 2. And then this must be set to a 9. Okay, so this actually takes me to the previous homework. So if I have an exponential equation, so I have the x squared on this side, I'm going to write this as 3 squared. Now, on the previous homework, we were always getting the same basis, and we were setting the powers to each other, equal to each other. Here we have a similar case, but little bit different. If the powers are equal and you have an exponential equation, that makes your bases to be equal to each other. So because both of them are raised to the power of 2 and they're equal to each other, this guarantees that x must be equal to 3 for question 11. For question 12, I have this homework question now. I have log base 2, 64, and this is set to an x. And I need to find out what x is. I don't have to convert this to an exponential equation to answer because this means 2 to the what power is 64. Okay, so as we know, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, so 2 to the sixth is 64, right? So I know that x must be equal to 6 because 2 to the sixth power is 64, so that's how we get 6 for question 12. And then question 13. For question 13, I have log base 7, and then this is 2401 is equal to x. That's such a big number, but given the fact that the base is 7, so if we just try to write the basis of 7, 7 to the first power is 7, 7 squared is 49, and then 7 to the third power is, now I have to multiply these two numbers, and I think that's all I get there, right? If I didn't make a mistake, 7 times 9 is 63, 6 is the carry, 4 times 7 is 28, and when I add, okay, this is all I get. So 7 to the fourth power now must be this number multiplied by 7 one more time. So I have to do the multiplication here because I can't do this in my head anymore. That's 21, 3 is the carry, and then that's exactly what I get here. When I multiply 7 4 times by itself, I need to get this number. So that means x must be equal to a fourth power. So 7 to the fourth power will be equal to this number because log means the power, and this is how we do number 13. The last question on the homework is number 14. It is log base 2, and then I have x squared plus 1 here, and this is set to a 2. I'm going to go ahead and convert this to an exponential equation again. And if we repeat one more time, the base is 2, and then we're going to raise base to the power given here, which is 2, and then we're going to make it equal to x squared plus 1. So this is a 4, and this is x squared plus 1. Subtract 1 from each side. So this is 3 is equal to x squared. So to solve for x, we need to take the square root of 3, and then it will return two answers, positive and negative. So, oh, this one, it didn't ask me to, I believe, first it says change the logarithmic equation to exponential form. Since we already solved here, let's just make this bigger. And then I think this will allow me to now type my answer here. So first, I think it might be coming in parts. First, we're going to change this to an exponential equation. So we know that it is 2 to the power of 2 is equal to x squared plus 1. So I will check my answer so far. And then now, once we solve this by 4 is equal to x squared plus 1 and subtract 1 from each side, I am going to get plus and minus radical 3 as the answer. And this is how we do question 14 on section 6.4.